We were looking at Section 8.5, which is sinusoidal regression. So we're going to determine the sinusoidal function that best approximates the data and answer questions based on sinusoidal regression. We've worked with regression before in the other units. In Unit 5, we've worked with linear, quadratic, and cubic regression. In Unit 6, or in Chapter 6 rather, we've looked at exponential regression, and in Chapter 7, we looked at logarithmic regression. So what we did is we determined with technology, we found the regression function, and we answered questions based on the characteristics. So we're going to do that again now with sinusoidal functions. So we've looked at 5 types of regression: your linear, your quadratic, your cubic, your exponential, and your logarithmic. Now we're going to look at sinusoidal regression. If you recall, the line of best fit is a straight line that best approximates the trend in the scatter plot. The curve of best fit is a curve that best approximates the trend in the scatter plot. If you're interpolating, it's the process used to estimate a value within a domain of a set of data based on the trend. If you're extrapolating, there is a process used, it's the process used to estimate a value outside the domain of a set of data based on a trend. So if you recall, there are some characteristics of a sinusoidal function that now, with the sinusoidal regression, both the equation and the graph, we have to investigate. So we're looking at the minimum, which is the lowest y value, and the maximum, which is the highest y value. The period, which what it takes to go from the maximum to maximum, or double what it goes from the maximum to the minimum. The amplitude, which is from the midline to the maximum, or the midline to the minimum. And of course the midline, which is halfway between the maximum and the minimum. So if you recall, the equation of a sinusoidal function, we had sine and we had cosine. And you had the amplitude was A, and the midline being D. The minimum value would be D subtract A. And the maximum value would be D plus A. The period would be 360 divided by B, or if it's in radians, 2 pi divided by B. The horizontal translation C, where the horizontal translation for a sine graph would be the first midline point, and the horizontal translation C would be where in the cos graph is the first maximum point. So when you use technology in class, you would have took a table of values and put it in your graphing calculator or some form of technology, and maybe even a computer program, Excel. And you would have used sinusoidal regression, and it would give you the variables A, B, and C, and D. So when you represented sinusoidal regression in an equation, this is what it would look like. So let's jump right into an example. The height in inches after time in seconds of a pendulum of a small grandfather clock is given by the sinusoidal regression shown. So here's the sinusoidal regression. Here is the regression function, and once again you would have been given a table of values and asked to determine the sinusoidal regression. You will not be, it will be difficult for you to determine the sinusoidal regression function, since you'll need technology, and we can't be specific on what type of technology you would be able to take into the public exam. Graphing calculator is permitted, yet it may not be available to everybody, so we cannot use that. The function most likely will be given to you, or the graph will be given to you, and you will have to answer questions based on the characteristics. For example, in sinusoidal functions, we looked at amplitude, range, we looked at period, and maximum and minimum, and midline value. You will also get questions such that if giving the regression function, you can put numbers in the regression function and answer questions. You may be able to estimate, using the graph, be able to estimate, if I said estimate the time, estimate the height of the pendulum after 3.5 seconds, then you could possibly say that it would be down around 66.5, since it would be the next point you're at your maximum, and the next point would be your midline for a sinusoidal function. So you would have to estimate and use the graph to answer questions and such like that. Let's continue here. What is the amplitude? And the amplitude, we are given the function, so we can say the amplitude is equal to A. In this case, it would be 1.5 inches. The range, of course, which is still D subtract A is less than or equal to Y is less than or equal to D plus A. And we can look at our equation for D subtract A and D plus A. And we have 66.5 subtract 1.5 is less than or equal to Y, which is less than or equal to 66.5 plus 1.5, that would give our range to be 65 is less than or equal to Y, which is less than or equal to 68. And Y belongs to a set of real numbers, of course. If we're looking for the height after 4 seconds, you notice it's not on the graph, but yet we can possibly estimate what it might be. We have a maximum value at 3, and as you can see, every half of a second it does the next key point. So we have the maximum at 3, so therefore at 3.5 would be the midline. At 4, we could possibly be down to its minimum again, so it would be somewhere around 65, somewhere around there. That's based on the trend. If we put 4 seconds in the equation, we can tell exactly what it would be from the table. So let's do that. We have 1.5 sine 3.141 times 4 subtract 1.570 plus 66.5, and this would give us 66.796. So that's where the height of the pendulum will be after 4 seconds. So here's a another example. An angle of a moon on various days is shown by the sinusoidal regression function below. So here we have the graph and both the function. Once again, you may be asked to use the graph to estimate a value without even having the function there. You may be given the function and asked to plug in values. You could also be asked for different characteristics based on the function or the graph. Like, we can look here and we could see that the midline must be somewhere near 40. And of course the equation shows us it is 40, 40.284. The maximum would be very close to 65, which is probably 63 or so. Right here is almost at 65, and the minimum would be about 16 or so. So you could answer questions like that based on the graph. We could also answer questions given the regression function. We can answer these questions as well. So we'll continue to do. What is the equation of the midline? And as we know, the midline equals D in the equation. We know it's somewhere around 40. And so it is Y equals 40.284 according to the equation. The maximum angle, that's going to be D plus A. And so we have 40.284 plus 22.954, which the maximum is 63.238 degrees. That is the maximum angle. The minimum angle will be D subtract A, which is the same. We have 40.284 subtract 22.954, and this would give us 17.33. This is what is the angle on day 30. And so if we just check, we could see on day 30 we're somewhere possibly just over 40, 45 or so. And so when we put it into the equation, we can tell what it would be on day 40. it's going to be y equals 22.954 times the sine of 0.230 times 30, day 30, subtract 0.208 plus 40.284. And when we use our calculator to do this, we get 42.958. And once again, that's not exactly what's on the graph, but it is what the trend tells us. So in summary, you will be expected to answer questions using the graph of the regression. You will be expected to substitute values into the regression function to answer questions. You'll be given the type of regression, that is, you won't have to look at a scatter plot and determine what type of regression it is, if it's linear, quadratic, cubic, exponential, logarithmic, or sinusoidal. You will be expected to answer questions on the characteristic of the function or of the graph of the function. So if you're given the equation, you'd have to determine the domain, range, amplitude, maximum, midpoint, things like that, or if you're looking at the graph. As for being asked to do a regression, once again, you will need technology for that, and we're not required to have technology in the public exam. So we're looking to just answer questions on the characteristics of the type of function that's given, and you'll be told the type of regression.